In this video, we're going to see how to use a burette in titrations. If you need to review the jargon of titrations, please pause and review this screen. So first we're going to get our 0.1000 molar sodium hydroxide and pour some into a beaker. Now we're going to make sure the stopcock is closed, and we're going to fill the burette with a bit of sodium hydroxide to rinse it and ensure that when we fill it with our titrant in just a moment, we're just as close as possible to having a perfectly pure standard with no water or impurities or anything else present. Now also notice I'm holding the funnel a bit above the neck of the burette. It's still nested inside, but there's an air space so that as the liquid fills in, the gas can escape without bubbling up through the funnel. Now I'm holding my gloved thumb over the top and washing all of the inside with the solution. And now this small wash goes into our waste. I've actually added a bit more than usual so that you'll be able to see the solution as I wash back and forth. Usually 5 milliliters or so is more than enough. Much more than that, and you'll start to waste your titrant and generate a lot of waste. Now, many people like to dump from the top of the burette because it's slower coming through the stopcock. You're better off coming through the stopcock, though, so the nozzle is well rinsed. Now at this point, the burette is clean and ready to refill with titrant once it finishes draining. In a moment, you'll see me close the burette stopcock again. Always remember this step. The clamp you see here is the one you should always use with a burette, not the ones you see in the bottom right of the screen. The pincer style would let this glass tube, filled with acid or base, slide and shatter. Now I'm going to fill the burette near the top, but it does not have to be right at the 0.00 milliliter marking. In fact, we need to bleed any air bubbles out of the tip of the burette, so we're about to change how full this is anyway. Now I've frozen time for a moment so you can spot the air bubble in the tip here. That has to go. Otherwise, when we start measuring, some volume that we thought was dispensed will just be used to refill this bubble. Getting rid of the bubble can be an art. Try toggling the stopcock on and off very quickly. And now the burette is ready to be used. We need to record the initial volume. Notice that we have 0 at the top, so we're counting down. We need to record the correct significant figures. Since the ones place is explicitly marked, and so are the point ones, we ballpark the 0.01 milliliter place. To my eye, that's 3.30 milliliters. Make sure that you have your eye level with the meniscus, or your reading will be off due to parallax. Don't record this number on a paper towel or something. Put it straight into your notebook. Just a quick reminder about what parallax means. If you look at something on an angle, it lines up with the wrong thing. Like a passenger seeing your speed as 50 miles an hour when you're really doing 55. Right, now the burette is ready to titrate. It's time to set up our sample, the analyte. I've already used a volumetric pipette to dispense a known volume of the analyte to this flask. Now I need to add an endpoint indicator to my analyte. About 3 drops will do. This indicator is phenolphthalein. When it's an acid, it's clear. In a base, it turns pink. When we add just enough base to react completely with the acid, we'll cross from acidic to neutral and to basic in a matter of 1 drop. So this indicator lets me know when I'm done titrating. If you forget to add this, your experiment will go nowhere, and you'll have to restart once you realize what happened. So remember it. Now I've adjusted the height of the burette so that the tip is just inside the flask. That way I have no splashes escaping. Now we start titrating. We can be doing about 3 drops per second here at the beginning. Make sure you are swirling constantly and avoid getting your base high up on the flask walls. It's hard to spot a color change against a black background, so I like to put a paper towel on the base to give a bit more color contrast. In the moment, it's easy to turn the stopcock the wrong direction. I think of it as a toll gate. When the gate is flat, everything stops. When it's up and down, traffic goes. Notice that nearly all of my attention is on how fast the drops are falling and whether this color is starting to appear. I don't care about the volume yet. Now the pink color is starting to appear more and last longer, so I want to slow down the drop rate. I also want to make sure that the drops aren't falling into the center of the whirlpool, otherwise the titrant isn't spreading throughout, and I need even mixing to correctly find the endpoint. Now I'm making sure that any splashes are rinsed back down into the solution. We're close to the endpoint, so every drop matters now. At this point, I could even start to go one drop at a time. The swirling is really critical now, so your hands need to be careful in handling the stopcock while you keep swirling. What we're looking for is a slight pink color that lasts for about 5 to 10 seconds, then disappears on its own. But pink color, because of poor mixing, doesn't count. What will happen is at the end point, the solution will suddenly turn basic. That means we added a tiny bit too much base to our acid. We want that gap to be as tiny as possible. If it's really close, the carbon dioxide from air dissolves into the water. It makes carbonic acid. If we have a tiny overshoot of base, the solution will turn from acidic to clear, to basic and pink. Then after a few seconds, the CO2 makes it neutral and clear again. See how the pink is lasting longer each time now? It won't be much longer, so we need our fingers to be ready to turn off the stopcock. And here we are. You can see that without swirling it isn't mixing well. So I'll give it a good swirl. Nope, still needs another drop or two. There are also some fancy tricks we could use to dispense a smaller drop. We can get a part of a drop hanging and spray some DI water along the edge and transfer it down. Notice that in the math later on, the volume that we have down there doesn't actually matter in terms of how much water is there. We can get away with adding extra water and the dilution won't do much to it. So that's one trick we can use to transfer partial drops. We can also touch it to the side of the wall and rinse it down by swirling our solution. And there's a few other tricks like spinning the stopcock really quickly so you get a half drop dispensed without accidentally dispensing too much. Some of those are some nice little tricks we can pick up as well. Now we can get fancy here by getting about a half drop hanging from the burette, turning off the stopcock, and touching the drops to the wall. But my thumb locked up and I got 2 drops instead. Now notice that I had a whole drop fall in and another half drop is hanging there. The hanging drop has been measured as dispensed. So I had to transfer it, which made it more pink than I was aiming for. So my end point will be a little bit higher than my equivalence point. Note the distinction. End point is when I measure, and equivalence point is where a perfect 1-to-1 ratio of moles was present. This means I'll be overestimating the concentration by a little bit. Now let's see how badly I did. I'm not relying on my bad breath to cheat. Remember when I said about carbon dioxide? A really good endpoint will turn back to clear after about 1 breath's worth of carbon dioxide. So it took me about 4 breaths. Still not terrible. After all, there's not much carbon dioxide in our breath, and only some of it dissolved into the solution. Also, we added about 1 drop too much. It's helpful to realize that there are about 20 drops in 1 milliliter, so 1 drop equals about 0.05 milliliters, right about where my significant figures cut off anyway. So remembering to read from the top down, we're bigger than 13, bigger than 13.5, looks like 19.93 milliliters to me. So we'll record that into the notebook along with the concentration of the titrant. We now know the concentration of the titrant and its volume, and we know the analyte's volume. So we can calculate the analyte concentration with M1V1 equals M2V2. And so that's the end of our titration video. At this point, we would have enough data for us to calculate the unknown concentration of our analyte down there in the Erlenmeyer flask.